So I actually don't see the presentation. Am I supposed to be seeing it?
No.
Okay.
Well, good evening, everyone. Now, welcome to another episode of After Hours in the STEM Center with Rand Spobo. So tonight we have a very special guest, one of our own from Kenyatta College, an instructor, the engineering instructor, in fact, Dr. Ramki. Dr. Ramki, welcome to the stage.
Thank you, Rance. Good evening, everybody. I guess this is the first time I'm actually doing a webinar. So unlike my classrooms, I don't actually get to see y'all while I'm giving the presentation. So I'm just going to assume that you all are out there and looking forward to a fun next 45 minutes to an hour. One of the things as an instructor, as a teacher, is that we really love it when students ask questions. So please do type in your questions as we go along. Anything that comes to mind, anything that interests you, just type it in the question answer box, and Rance will reach out to ask the question. Okay, so let's get started. So what I want to talk to you about is partly my life story, and also hopefully some tips that I've learned that can help you as you are beginning your life and your career in the discipline of your choice. Okay. So that's why I titled this talk, College, It's a Great Place to Be. What I'm going to do is, hold on a second here. Okay, should be share my screen. All right, so hopefully you can see my slides now. And so what I'm going to do is basically introduce you.
We don't actually see the presentation. We see the presenter slides.
Can you see the presenter slides?
Yeah.
How about now?
There we go. Now we see the presentation.
Okay, good. Okay, thank you. All right, so what I'm going to do is, split this presentation up into 3 parts. First, I'll give you a summary of what my STEM career has been thus far. And that is till about 2016. And at that point, I transitioned and a new journey started beginning for me. And I'll explain to you how I've now come to be at Kenyatta College, which I joined in the fall of 2019. And then after that, I'm going to give you a few tips, 6 in particular, about what I think can help you succeed in college and beyond. Okay, so let's begin with, a little bit about myself. Maybe you can use it as an example of what you might want to do or what you might not want to do. Right? So how did it all begin? How did I, end up being in STEM? And of course, all of us are, trying to find the thing that we like to do and we want to do, and also align with a lot of other requirements we have in our life. Taking care of family, taking care of a near and dear, thinking about the environment, thinking about our own career. Will I be able to make a good living? All those questions are coming up, right? And so let me tell you how it all began for me. It begins with having support around you, right? Obviously, family support is good. But remember, family support can sometimes be very direct, and sometimes it can actually be indirect. One type of support could be, okay, go ahead and become whatever you want to be. Right? The other type of support could be, this is what you should become. All of these are examples of support from the family, right? Something else could be, okay, do what you like to do. Oh, maybe you should be painting. Maybe you should be doing music. Again, this is the type of support that family gives. In my case, the one example that I think stood out to me when I think back to the support I got was, go ahead and read whatever you want and whenever you want. Now, with that, the two other important factors that I found to be very influential in what I decided to start out doing were my friends as well as my teachers. It was not about telling me what to do and what not to do. It was really about they doing things that they liked, from which I learned, right? And one of the things that I learned to do from all of these supporting cast, I would say, is to read storybooks. And on the screen here, you see the cover of one of my all-time favorite science fiction books. And Jules Verne, he's a French author. He's one of my favorite science fiction authors. He wrote this book called The 20,000 Leagues Under the Sea. And he wrote this book in about 1887 when, there was really not a submarine around. Of course, people had thought about submarines in the past, but there was no actual working submarine at that point. But he came up with this, grand idea of how the submarine would be powered, how it would move, how it would navigate, how it would generate oxygen for the people inside. And so for me, as a middle schooler, when I read these kind of books, it would take me a long time to finish one of them. And the reason was that, every time something interesting came about, I would get so excited that I would want to try out something. And this was in a way, it was very good because books like this just let you escape into worlds that were not really possible to be in, right? And so when I think back, one of the biggest influences in my life were getting access to books, especially science fiction books and comic books. Comic books I used to love to read because, they had pictures and they had a story. So it was really a lot of fun to, quickly finish a book and feel really good that you actually read a book. Right? And so this was kind of where I think the seeds of going into the STEM discipline started for me. So let's talk a little bit about books. Today in my home, there are books littered all over the place. This photograph is actually from a bookshelf in my garage. And although I have a lot of books, I have to be honest, I've actually not read many of them, right? So here's what I want to do. I want to start by taking a poll with all of you involved. So the question is this. Think about a non-technical book. It has nothing to do with your classwork or the college study that you're doing. Think about, the story books you might have read, fiction books that you might have read, things in history, in art, and take this poll here. Okay, I'm going to launch this poll and answer this question. Choose one of the options here. How often do you read? Once a year, once every few months? I start but rarely finish. I don't read since I can't find access to free books. So just let's see how this goes. I'll give you all a minute or so to take this poll. So Rans, let me know when you think everybody is polled or close to everybody being polled. Is that the number of folks we have on? About 12 right now? Okay, good. Okay, so it looks like everybody has polled, and here's what it looks like. Right? Most of you chose once every few months and about once a year, and that's fantastic. For me, I actually fit into the third category. I start but rarely finish, and that's become a real problem for me. On the other hand, I found that to be very useful because, the beauty of a book is that you don't have to read the whole book to get the entire idea that the book is based off. It has ideas all over. So even if you take bits and pieces of it, you quickly browse through it. pick up a chapter that catches your attention and read through it, you can still get something useful out of it in terms of imagination, in terms of idea, and simply in terms of escaping into a different world, especially in today's environment where we need to be able to shut out a lot of noise that's around us. So I'm delighted to see that all of you are reading books. This is fantastic. Okay, so I would say please keep that up. Now, one of my favorite places to get free books is actually sorry, of course, you have access to the college library, which is one of the best reasons to be on a college campus, in fact. And then, of course, the public and county libraries and the city libraries are tremendous resources for books as well. But for those of you who like to read books on ebook devices, the Project Gutenberg is actually a very good site to get free books, especially some classics that you will never find in a library. You can get it at this website here. So do check that website out. Everything is free on that, and so it's pretty amazing. Okay, so getting back to this influence of books. By the way, here's a picture of what Jules Verne sketched on in one of the pages of his book. This is the submarine that he describes in the book. Its name is the Nautilus, and what he described was that the Nautilus was powered using batteries, and these batteries were actually using sodium as one of the electrodes, and this sodium was being extracted from seawater. And also, to generate water for the submarine, he used the process of distillation. Now, this was back in 1870. Okay, and so some of these concepts were already around, but remember that the submarine was actually not functioning at that time. There was no functioning submarine, so it was in very much a science fiction, which now is complete reality, right? And so that's one of the things about science fiction. You read science fiction now, maybe in 20 years time, you have something that was described in a science fiction book. Now, for me, what was happening is that whenever I would come across an interesting idea, I would get completely distracted. And so I would put the book down. I would not be able to read further because I wanted to kind of figure out what this idea was all about. And that's why it took me a long time to read books, because I would just be distracted by all these excellent, brilliant, crazy ideas that were being put forward in the books. And that also made me realize something else, and that was that if I really wanted to understand some of these things, maybe I should actually start learning some math, some physics, some chemistry, and some engineering. Right? And so I would say that this was a big influence in me, kind of gravitating towards the STEM discipline, trying to pursue and understand the ideas in some of the science fiction books. So what did I do then? Well, once I finished college, once I finished my high school, I had kind of crystallized in the fact that, okay, I want to go into a career that would utilize my interest in math and physics. And so I went to college. Okay? And I started by actually wanting to major in math. And that's how, I went in. I said, you know what, I want to actually just do math. But about a year after being in the math discipline, although we were freshmen and many of us did classes that included things like physics and gen ed, somehow, when I started talking to my buddies in physics and the other disciplines, I felt they were having a lot more fun in what they were learning. And so that kind of had a strong influence in me. And that made me change to physics. So in my second year of college, I moved from math and I moved into physics. Now, at that time, in the education system I was in, which is in India, it was impossible to do a double major. You could not try to do two majors. The only way to do that would be you finish one degree and then you come back to school and then get another degree. And so I had to make a choice. It was either math or physics. I couldn't do both. So, I thought hard about it. And then I realized that one of the things that was missing when I was reading the books was actually being able to touch and make and do things. And that was something that physics gave me that math couldn't. And so that's why I ended up eventually in physics. And that then led me to the fact that, you know what, physics is also not for me. I actually should become an engineer. And that's when I actually migrated to the United States. So I came to the US in 1995 as a graduate student, and I came for my PhD in engineering, and my PhD is in material science. And I went to North Carolina State University, which is in Raleigh, North Carolina. And at that time, so around the time that I was coming to the US around 1994, about 8 years before that, there was a major breakthrough in the field of material science. And this was the discovery of high temperature superconductors. And I don't know how many of you have heard about a superconductor, but I'm going to play you this little video clip here and ask you to just keep an open mind and then decide whether what you're seeing is science fiction or is it real. Okay, so here it goes.
So what if we got here? So we have quantum locking. The superconductor is locked in space and it stays wherever I put it. You see, this is quantum trapping.
It's amazing.
As long as it's
so the
cold,
it's superconducting. It's frozen with liquid nitrogen.
Upside down.
Right.
And it stays locked.
So the fact that it's superconducting is locking the magnetic field in 3 dimensions, right?
Yeah, exactly.
And that's
pivots. You see, because this is symmetric, it can rotate without break the locking. The locking doesn't break.
Right.
Because
it stays there on the X and Y, but not on. But it pivots on the
on the axis of the magnets. You see, if I can move it on the side, it will again pivot around the axis of the magnet because it makes sure that the magnetic field inside of it stays the same.
Right. It's astonishing. Can you put it on the track for us?
Yeah. I just levitate it above the track quite high, and I can just rotate it.
So it's actually floating above the surface.
Yeah, it's not floating; it's locked above the surface.
So you could tilt it at an angle, and it would still fly
I can
around.
do it like this, and it will just go around like this. Because I go and put it at different height, put them like this.
And lock it at the height.
Lock it, different height, different configuration.
Right.
And I can even lock it the opposite way. If you could just hold for a minute. High. I'm doing the same thing. I'm locking it upside down, and then it is suspended.
Fantastic. Okay.
Okay, so you can imagine, you know, as somebody just coming out of school, thinking about what to do in science and technology. You hear about a Nobel Prize in superconductivity, and you start thinking about it, say, man, I need to go into that area. And so I actually ended up doing my thesis in this area. Although I worked in the area of superconducting thin films, which don't produce as cool videos as what you saw here, because what you're seeing here is a video which has a bulk superconducting material. Nevertheless, it was an amazing subject to work on. By the way, so one of the big dreams of people working in the area of superconductivity is to, of course, to reduce the amount of energy we use, especially from greenhouse gases, because you can significantly enhance the efficiency of machines. If you think about an internal combustion engine, for example, if you have a regular gas-powered car, the efficiency of that engine is only about 20%. If you have a diesel-powered car, the efficiency is close to 40%. But if you have an electric motor that's actually powered by the superconducting material, you can get efficiencies up to 95%. So that's a huge improvement. And so there is a major effort around the world to try and get these superconducting materials to behave like they do, closer and closer to room temperature. The one that you see here was actually cooled down to about 77 Kelvin, which is the boiling point of nitrogen. And so clearly it has to be kept very cold in order to be able to see its effects. Nevertheless, it's an amazing field, and I really enjoyed my time while I was in it. So here's the deal. I was in college and got my undergraduate degree, got a master's degree, and then went on to a PhD. I had been in college for a really long time, from 1986 till the time I finished my PhD, which is 1998. So that's 12 years. Right? So at that point, I said, let me do something else. Let me try out what the industry looks like. And so I decided to give that a shot. Okay? Now, since my passion was in materials, if you were to actually look at history and try to correlate it with how human civilization has progressed through time, the one big correlation you will find is the advance in the materials that these different civilizations have used. So in other words, if you think back all the way to when we were starting to, form a society, at that time, the tools that people were using were pretty much made out of stone. Okay? Then slowly it moved to the metal age. It began with bronze, which is an alloy. So it's a mixture of two metals. One is copper, the other is tin. Then it went on to the Iron Age. And then today, one can argue we are in the age that is dominated by silicon. And the reason for that is that silicon is the basis for all the logic and computing that we have in our computers, in our cell phones, any other electronic device you can think of. So the silicon era, it really began in about, 1947, where when the transistor device was invented. Now this device was invented at Bell Laboratories in New Jersey. The three scientists, Walter, Badin, and Schreiber, they actually won the Nobel Prize for this invention. And the reason I tell you this is because I got the opportunity to actually go to work at this place, this industrial laboratory called Bell Laboratories, which was part of the company called Lucent Technologies. In fact, I had this 2-year opportunity where I would work at this industrial lab, along with partnering with a national lab, which is Oak Ridge National Lab, which, by the way, was the center for the nuclear program in the US. And so it was a very exciting opportunity. I said, this is too good an opportunity to miss up, so let me go try it out. So for 2 years, I actually worked at Bell Laboratories, and I carried out research looking into how to improve the properties of silicon so that we could make better transistors. Really, my focus there was on developing new processes to modify the properties of silicon so that we could have cheaper and more effective ways to manufacture the type of silicon we would need for the transistors that were being made. By the way, Jack Kilby, he was an engineer, and in 1958 he came up with this idea of basically putting together different types of electrical components and integrating them together. And what he had discovered in his notebook, he basically sketched out this idea in his notebook. What he had discovered was essentially the pioneering process called integrated circuit technology. That means you put together a resistor, a capacitor, an inductor, a transistor, a diode, and everything together to form different types of input and output signals. And that basically was the birth of the integrated circuit era. And now, of course, everything we have in terms of electronics is basically a chip that is connected to other chips and doing certain things that the particular device wants it to do. So he's one of the pioneers in this area. Another pioneer is Gordon Moore, and the plot that is shown here is something known as the essence of Moore's law. And what Moore's law is that what he actually kind of empirically predicted was that every 2 years. So if you look at this law carefully, you can see that between the years of 1959, which is the first data point, till about 1965 or 65, there are about 1, 2, 3, 4, 5 data points. And then everything else is a projection, right? But what he said is that based on these 5 data points, he said that every 2 years, the computational power is going to double in terms of the number of transistors we're going to have on a chip. And believe it or not, even today, today is 2020, so that's about 60 years later, the law is still being followed. So basically, our technology is really going at this particular rate that is shown on this plot that was developed in 1965. So that's called the Moore's law. Okay. So after 2 years there, it was a lot of fun. I had a patent. I had many publications, but I realized that somehow my heart was still to be in college. Yeah? I began to miss being in a college environment. And so my next step was that I went back to college to become a professor. Okay? And now I have to give you, what a college professor is in terms of being in a 4-year university in the US. If you want to become a professor in the US, one of the things you have to achieve is called tenure, right? You start out as being an untenured professor, and then you have to meet certain benchmarks, certain metrics, and then eventually you get to become a professor. It takes anywhere from 4 to 7 years. Right? Now, the component of the biggest component of becoming a professor in a university is the research part. And you have to essentially publish a lot of papers, you have to write books, and one of the big factors is you have to get in a lot of money into the university by writing grants to the federal government or to industry. And the funny thing is, teaching is actually a very small part of your responsibilities when you're a professor in the university. You teach maybe one class a semester, or maybe one class a year, depending on how your research is going. So anyway, I started out there as a professor, wanting to do research. And one of the areas that had by that time that I had really got interested in was the area of nanomaterials. Now, what you see here in this image is a glass cup that was basically made in the year 400 AD. This glass cup is actually housed in the British Museum in London, and it is known as the Lycurgus Cup because it depicts King Lycurgus on the design. And this cup is what is known as a dichroic cup. So dichroism means 2 colors. So di is 2 and chroic is color. So it is 2 colors. And what that means is that if you shine light on it, the light you get in reflection, in this case, the red light you see here, is different from the light you get in transmission, which is shown in green here. Yeah. Now, it took till about 1965 for people to actually figure out why this material was actually dichroic. Now, how did the Romans in 400 AD figure out how to make dichroic material? Because at that time, materials processing was extremely rudimentary. I mean, it's very simple. Right? So it turns out that this is the first example of a man-made nanomaterial. Okay? And the color in this cup is coming because these artisans who made the cup had figured out that if you take sand from a specific location and you heat it up to very high temperatures in order to melt it and form it into glass, and if you cool it down in the right way, you end up making this type of glass. And what they had accidentally discovered is that the sand that they were using actually contained a lot of silver and gold in it, and the way they were heating it up, melting it and cooling it was resulting in a lot of the gold and the silver forming tiny nanoparticles inside this glass. And that is the origin of dichroism in this material. They didn't know that. It took up until 1965 when you had powerful microscopes that could look into the glass and look at its internal details when scientists actually realized that this was actually an example of a nanomaterial. So going back to my career in the college, I spent my I would say first half of my career was in the physics department at Washington University in St. Louis. It's a private school. And that's where I started, getting into this area of nanomaterials. And I should say a lot of my work was actually experimental in nature. So I built a lab, and I had a number of graduate students who worked with me and graduated with their PhD. They had primarily experimental dissertations, and so it was a lot of fun. And just to give you a sense of why this area of nanomaterials was so interesting, if you actually start looking at around you, you'll find that nanotechnology and nanomaterials are, really everywhere. And I'll point out a few examples here. Let's say you think about, going to the beach on a really warm day. There's a lot of sun. You put a coating of, sunscreen lotion. I'm pretty sure if you look carefully at the sunscreen label, you'll see that it contains titanium dioxide nanoparticles in it. And that's, an immediate application of nanoparticles. The titanium dioxide is a very special compound that helps to absorb the UV rays, and so it protects your skin when you're out in the sun. And so if you go through this list, your hard disk, if you still have a hard disk in which you have a disk drive that is actually rotating at either 5400 RPM or 7200 RPM, those disk drives have tiny magnets in them that are storing your bits of data. And those tiny magnets are in the nanometer scale, in the tens of nanometers in size. And so that's an example of a nanomaterial. So in fact, the definition of a nanomaterial is that it is built up of components whose size are typically in the 1 to 100 nanometer range. Okay? And so there are many examples of them out there. Okay. Here's a question for you, and I'm going to poll you on this, and let's see what you think. So I'm going to launch a poll, and the poll is going to ask, do you think invisibility is a real possibility or not? Wow, this is amazing. The polls are pretty much being split 50-50. Okay, good. So the answer is that, yes, it is a real possibility. Now, for those of you who are movie buffs, as I said, I like science fiction, and I tend to like science fiction movies as well. Here's a great science fiction movie. It's called The Philadelphia Experiment. And I think it's a movie from probably the late 80s, early 90s. And it's about this experiment that the Department of Defense is doing, and they create this device that can pretty much make things disappear. Okay. Now, the experiment is actually about time travel. So what they discovered was time travel, but the ideas they were using are more consistent with being able to create invisible objects. So now, without getting into the details of how you can achieve invisibility, what I'll say is that it is a real possibility. Now, one thing is that, if you think about the Harry Potter movies and the invisibility cloak, now that's actually the ultimate level of invisibility, right? But there are other things you can do. You can probably make materials that are invisible in certain colors. You can make things that are invisible from certain angles. You can make things that are invisible in certain sizes. So there are different types of invisibility one can think of. So when I think like that, it turns out that there is a very definite pathway in which you can combine ideas in nanotechnology in optical materials, especially this field called plasmonics, which is an exciting branch of optics and magnetism. And the combination of these three, when they're done right, you can actually get invisible materials. Okay, so it is not science fiction anymore. Okay, so that was my academic career working in these areas of nanotechnology. I had published hundreds of papers, I had patents, I had graduated 14 students, and there is something called the Google Scholar Profile, which tracks how you're doing as a scholar, how many people are reading your work and citing it, and so on and so forth. So that was going pretty well. And then in 2016, life began to change. And so now let me enter into the second part of my talk, which is my journey to Kenyatta College and how that all came about. So it began in 2016, about 2,500 miles away. I was in Knoxville, Tennessee. And I had decided that, I needed a break from what I was doing. And so a very good friend of mine at UC Berkeley, he was gracious enough to host me for a year-long sabbatical, working with him in the material science department at UC Berkeley. Yeah. So my family decided that this is a great opportunity to take a road trip across the country. And so we decided, to get onto a minivan, 4 of us and with a dog, and just drive across and see the country. So we started in Knoxville, which is out here. And, we stopped at many different places. One of them, which is really interesting, is Little Rock, Arkansas. Or sorry, it's Hot Springs, Arkansas, which is close to Little Rock. And what you have here is a lot of underground vents that generate, that actually outflow hot water. And so if you touch, for example, the photograph here shows one of the springs, and if you touch it, the water is really hot. It's close to like 104 degrees. And so people used to come here because there was a long-standing belief that if you take a bath in these hot springs, you actually can, you can actually get medical relief from a lot of ailments. But at that time, this is 2016, right? And already in the media, there was a lot of misinformation starting to occur. And I thought it was interesting that this museum here actually advertised as one of its key attractions, that you could get facts if you go to the museum and not fiction. So it was kind of interesting and also ironic at that time. Our next stop was, or rather our next stretch was driving through the northern part of Texas, the panhandle of Texas. And if you get a chance to go to the panhandle, what you'll notice is a stunning, spread of wind farms. It's like it goes on for miles and miles. That area is pretty flat, and and so you can see for long distances, and everywhere you look, you'll see these windmill farms or wind farms. Right? Next stop, Santa Fe, New Mexico. A must-visit place for anybody who likes to travel. It's just spectacularly beautiful. Great food, great people, and we really enjoyed that part of our trip. And then we took a northern route. We actually went to into the Rockies, and then we stopped in the southern part of Utah, where you see these spectacular canyon formations, and drove south through Nevada, the Hoover Dam. Saw that for the first time. That was pretty exciting. And then finally, came to the Bay Area. But what we felt, as a family, we felt that we drove through all these places. It's pretty beautiful, but people are really poor, and that was kind of shocking in some sense, because America is such a rich country, but you see that there is so much poverty here. And so this kind of started causing some problems for me, in the sense that I started thinking, what am I doing here? I'm in the university, and but I don't seem to be connecting with this bigger problem that seems to be out there, right? So here's another poll question now, and let's see if how many of you know the answer to this. So let me just share the poll here. Okay, sorry about that. Let me stop sharing this, and not for the new poll. Okay, so this poll is now. I want you to tell me what you think the mobility factor measures. Okay, I'm waiting on one more to vote, and then we'll have a look at the spread. Okay, good. So let's share the poll here. And as you can see, most of you selected option C, the probability of you earning more than your parents, and that's correct. By the way, those of you who selected B are also on the right track, because it turns out that in semiconductor physics, the mobility is actually an important measure of how electrons and holes move in the material. So you're not far off. But what we're talking about here is the mobility factor. And the mobility factor measures, what is the chance that you are going to end up earning more than your parents. By the way, uh, I don't know how many of you know what the mobility factor is. Since we can't directly interact here, I'm going to show you what the mobility factor looks like now. So back in the 1940s, around the time, around World War II, there was a 90% chance that you would earn more than your parents. And you look at this slope, look at this plot here. This is from the Equality of Opportunity Project, and you can go to the website. They have tons of really cool data that is related to economics. And what they found is that today, so this plot is up to 1980, but today the mobility factor is less than 40%. And so that's shocking, because what that is saying is that only 4 in 10 people can actually end up earning more than their parents. And that's really shocking, given that we are supposedly the richest country in the world, right? And the reason for this is also correlated with the fact that most of the income in this country is actually with the richest people. I'm sure you have already realized by now that over the last 4 years, including this pandemic, the extremely rich have actually become much richer, but most of the other people have not really benefited from whatever policies that the government has employed. So anyway, so for me, this was really troubling. I said, how can this be that we are in such a state here that people are unable to achieve the American dream, the so-called American dream, because this is really what it is. What this is saying is that the possibility of you achieving an American dream is actually very small now as compared to the 1940s. Yeah? So here's where there is good news. And this is where I what changed my opinion about the whole thing. It turns out that a college degree is the number one way to get out of this situation. So here's data that shows some very interesting research that was done in New York, and it was trying to address this question of how do you enhance the mobility of somebody, right? So they looked at data from the State University of New York at Stony Brook and at Columbia, which is a private school. And what you see in blue here is basically the number of students. So along the x-axis is essentially telling you what the income of the parent is. Okay, so 1 is basically telling you that these are students coming from the poorest set of parents, and 5 is from the richest set of parents, right? And on the y-axis is plotted the percentage of students from these various cohorts and how they end up doing in terms of their earning potential, their success rate in terms of how much they earn. So the great news is this. One thing you see here is that across the board, if you look at the red data line, which is the success rate of students who went to Stony Brook, you can see here that Stony Brook has a larger number of people coming from the lower income, right, as compared to Columbia, which one might expect because Columbia is a place where you have to pay heavy fees to get into. And so what you see here is that no matter whether you went to Columbia or sunny Stony Brook, you still had a significant increase in your success rates. That means your income was significantly improved if you went. And so that's great news. What that tells you is that a college degree goes a long way in enhancing your mobility. And here's another way to look at it. If you look at the data from the Bureau of Labor Statistics, that basically shows, the difference between how a college graduate earns after they have graduated versus a high school graduate or somebody who has not even completed high school. You see that the only category that actually leads to an increase in the median weekly earnings are college graduates. Okay, and so that has gone up over time. So again, that's an indicator that having a college degree is long-term success, not necessarily tomorrow after you graduate, but over the long period of your entire lifespan. Having that college degree from 30 years ago would still be beneficial. Right? So this is where I decided, okay, this is what I want to do. I want to really change my focus and really get deeper into helping students succeed with their dreams of getting a college degree, especially in the STEM discipline. And that's how I ended up at Kenyatta College. Okay, so the final part of my webinar. So what is it that, what is it that you should be doing or you could be doing that could, help you succeed now and also in the long term? So let's go through some of these things one by one. So the first thing I'm going to look at is tell you what the formula for success is. Okay, so let's begin with the poll here, and we are going to try and begin by first understanding what it means to be successful. So we're going to focus on what is the definition of success. Okay, so I have provided 4 options here, and go ahead and see what you think is the definition of success. I'm waiting on one more to finish, and then we can end the poll and share it. Okay, great, excellent. Wow, this is amazing. So it looks like we have an excellent level-headed set of students here who are extremely motivated. So this is great. So if you are starting out at this point where you realize that success is based on achieving what you are setting out to do, you are on the fast track to being able to achieve that. Okay, so that's great and that's fantastic. So please keep that in mind. Every time you face a hurdle, that's where this idea of having the goal really helps you get over hurdles. Okay, so keep that in mind as you move forward. Fantastic. Okay, now it turns out that there is actually a formula for success that you can use. It involves a combination of talent and effort, which is something that we hear in our in our general social circles, in our discussions with or when we see movies, or when we hear the news, when you hear great people talk, all of them will say that effort is the number one thing, and also it requires some talent. The good news is that everybody has talent, right? And then it's only a difference of how much effort you put in. And this is how it works. The first level of effort and talent is something called skill. Okay, so skill is a product of your talent and your effort. Okay? Now, in order to actually be successful, that skill has to be put to good use, and that is done by putting in effort. So your success is really measured by the skill you have and the effort. Now, as engineers, as STEM discipline people, we like to work with formulas. So you can see where I'm headed. I have equation 1 and equation 2. And so now I'm going to rewrite my success in terms of these 2 equations. And so here's the number 1 tip that I have for you, which is the formula for success, which is a product of talent into the square of your effort. And so you can see here that even if you have a little bit of talent, putting in effort makes a huge impact in your ability to succeed, especially because success goes as the square of effort. Okay, so remember that everybody has talent. Some have a little bit, some have more, but without the effort, there is no way, or I would say it's very unlikely that you will succeed, which is to achieve your goal. Okay, that's tip number one. Okay, tip number two. Now, as you know, we are at a point where we have the ability to be distracted almost every instant of our life. You know, whether we are in class, whether we are, you know, lying down in our bed, or wherever it is. There's always a device nearby. It's always beeping. It's always sending you these, you know, these interesting sounds that make you want to pick it up and click on the message or whatever it is, right? And so when you think about it, this actually is a very distracting environment to be in. And I know some of you may have seen this movie, but I would highly recommend you see it. It's called The Social Dilemma. And really, it tells you how all these app makers, all these people who are so-called technology drivers, like the Googles and the Facebooks and the Twitters, how they are designing everything to make it more addictive for you to actually, you know, not let that phone down. Yeah. So in this environment, you know, where is it that you should focus your learning time? Okay. So here's the challenge. If you look at computer technology, which can be measured by how many calculations you can do per second, you can see that there's been a massive increase in computational power. In fact, if you have a cell phone, the cell phone you have today is much more powerful than a desktop computer from about 7 to 10 years back. And that's because, one, it's the Moore's law in action, right? Moore's law is basically allowing us to put more and more transistors into a smaller and smaller area. So in the palm of your hand now, you have this vast computational power. And so that makes it easier for all these complicated apps to actually run and keep you distracted. Okay, so keep that in mind. You know, with great power, which is this great computing power, there should be great responsibility. And unfortunately, that responsibility is not coming from the app makers. And so it's up to us to become responsible. And so here's the thing you can do. Focus on getting foundational knowledge, fundamental knowledge. And here's one way to think about what foundational knowledge is. If you are, you know, in a class and you are required to buy a textbook, or you need to have a textbook, buy one from 20 years ago. Because the foundational knowledge in that textbook is still the same today, and it will still be the same 10 years from now. The only thing that really changes is the figures, the examples that are put in there. You have new applications and things like that. But the foundational knowledge in the STEM disciplines does not change that fast. And so that's where you should be putting your effort. So that's my tip number two. You know, whatever class you're doing, make sure that you're focusing on understanding the basics. Okay, even if you don't get the applications, try and work and understand the basics. Because if you have the basics, then it's just a question of spending a little bit of time to apply those basics to any problem that you encounter as you move forward in your career. Okay, so that's tip number two. Okay. So let's go to the third part. Now, how do you find a career path? Okay. Raj, there is a question in the Q&A session. Do you want me to wait to answer it later, or?
No, you can answer the question as it comes in.
Okay. So so there's a question that's come in, and it is, did I have any major hurdle that I faced before I established my career? And if so, what was it? Yes. Yes. So let me tell you the one thing that almost derailed my entire quest to get a degree, and that was economics. Economics almost derailed it, because when you're coming from a fairly poor country, I came from India, so there, we are reasonably well off, but not in when you compare it to a middle class person in the US, for example. So there is no way I could come to the US without a scholarship. So the financial part was a significant hurdle. So in fact, what happened is that when I started applying for grants and scholarships to come to the US, a professor from one of the institutions offered me a stipend to come and do my PhD under his supervision. And so I was super excited. I got my visa, I got my paperwork done, and then when I was about to actually, about 3 days before I was supposed to board my plane, I get a call from the professor that unfortunately he doesn't have funding anymore, so he can't support me. And so that was a blow, because basically that killed my dream right there. There was no way I could come because there's no way to support myself and pay the few $1,000s a month that is needed to actually be in the US and do stuff. And so so basically that derailed my first attempt. Luckily, 6 months later, I had another opportunity, and I was able to come. But in the meantime, in those 6 months, what I did was try to basically learn some new stuff. And so I tried to make myself useful. As I was still getting over the shock, I gave some tests in India that allowed me to go for a PhD degree in India itself, and I was ready to do that. But luckily, in 6 months' time, things changed, and I was able to come. So hopefully that answers part of the question that you asked me. Now the second thing is, second question is, have you seen a significant difference in your career thus far between male and female recognition in the STEM field? Yes, the answer is absolutely yes. And so let me tell you my own experience. So I have graduated 14 students for their PhD degrees. Out of that, I had only two women student graduate. And so that's a shockingly low ratio when you think about the population as a whole. Unfortunately, that has been something that has been a huge problem in the STEM discipline. And part of that is stereotypism in terms of what women can do and what women cannot do, which is not something that I heard, but that was actually something that seemed to be systemic. That means women students who were in school were already getting that kind of feedback. And so by the time they came to applying to graduate school, there were very few applicants whom you could actually choose from to come to grad school. Now I have to say, my wife is also a PhD. So I know it's possible, but it takes them a lot more effort to cross over these several hurdles that society has actually placed. And in the end, they actually do much better. And my, by far, the best student I ever had was Humaira, who is a woman student. She came from Bangladesh, and she is by far the best student I've ever had. And there are many reasons for that, because they have so many amazing qualities. Maybe because of the fact that they face so many more hurdles, that for me it was an eye opener. I said, why are we not having more of these kind of students in our field? So hopefully that answers your question, Catherine. This question about what kind of student I was, were you extremely disciplined and had a set schedule for studying? The answer is that yes, I was disciplined. I would definitely do my homeworks on time. I would definitely try and prepare for exams on time. Although even under those circumstances, the night before the exam was always stressful. We were always trying to work hard into the night, which was a bad idea. Yeah? And so, but I would say I did work hard. when I was in college. Not during my undergraduate career, but during my PhD. Because there I started seeing that I really enjoyed doing something and I wanted to learn. And so that became a natural process. Is there a possibility you could bring nanomaterial research to Canada? Yes, it's definitely a possibility. It's going to happen in 2 years' time, unfortunately. I have to move my lab here, and hopefully that will happen next summer. And then after that, students will be able to do, take 695 or something like that and do some nanomaterial research. Okay, so that answers most of the questions right now. So let's get back to wrapping up the tips here. Here's the next poll. How many of you how many of these folks do you recognize? So let's get that going. So how many of these famous STEM ladies do y'all recognize? Okay, so I'm waiting on one more to finish it, and then we can look at the results of the poll. About 92% have voted. Okay, so let me end it right now. I think we have a good sample here. All right, so here's the result, and 10 of you have heard of one or more of them, which is pretty good, and some of you have not heard of any of them. And so let me tell you a little bit about them. Mary Jackson and Katherine Johnson are two famous African-American NASA engineers. Mary Jackson was actually known as a NASA computer. So if you have heard of the movie Hidden Figures, well, Hidden Figures is basically a movie that depicts Mary Jackson in it. She's one of the lead figures in that. So I would highly recommend you watch that movie because it's a brilliant movie. Hedy Lamarr is an actress, a famous Hollywood actress, but many of you will be surprised to know that she was actually a brilliant electrical engineer. She did not actually have an education, but she actually was responsible for creating some encoding signals that were used during World War II to encode and keep signals so that they could not be hacked into by the enemy. Okay? Ellen Ochoa is the first woman Hispanic a woman and Hispanic NASA scientist and engineer. She's a NASA astronaut. Mildred Dresslehaus is known as the Queen of Carbon. She was a professor at MIT. She recently passed away. She has done pioneering work in material science and especially in the area of carbon. Margaret Wu is a famous chemical engineer at ExxonMobil Corporation, where she worked on developing lubricants which are used in engines. And so, I use these examples in my classes to show you that there are many role models out there that could be like you, that you could use to motivate yourself to do great things, right? Okay, so let's end with 3 more slides here, 3 more tips. What type of job should I get? Well, one way to think about it is that what is it that you like to do? Not necessarily in terms of chemical engineering or physics or math, but what type of job do you actually like to do? Do you like to sit on the table and write stuff? Do you like to spend your time on a computer? Do you like to tinker around? Do you like to just think about analyzing data? And so this is what a typical engineer or a STEM major might end up doing. These are different types of job functions, right? You could be an entrepreneur. That means you're interested in creating new ideas and making them come to life. You could consult, you could teach. I'm a teacher, right? So the thing is that what I love to tell people is something that is said by one of the famous engineers around, whose name is Dean Kamen. He's the inventor of the Segway. And he said, if you can find something that you love, and what you should do is then learn to do it so well that you can make a career out of it. Okay, so in other words, it doesn't matter what it is, but if you love it and you can do it really well, there's going to be a career out of it for you. Okay, so keep that in mind when you're trying to figure out, as you go along, what type of job you want to do. Here's the thing I will tell you. There's a lot of stress thinking about the future of jobs in terms of robotics. we know for a matter of fact that a lot of jobs can be done by robots, right? But I would only point you to this very nice TED talk. I would highly recommend it. I'll share the slides so you can get the links. And that is that over the last 150 years, robots have been replacing our jobs, but the actual number of jobs have really gone up. And so there is a paradox here. So on one hand, jobs are being taken away by robots, but on the other hand, new types of jobs are being created by humans. For example, I'll give you just a simple example. 30 years ago, there was basically just one type of yoga that was being practiced around the world. But now you probably have about 10 or 20 different types of yogas that are being practiced. So this is the kind of stuff that's happening, that what we think is taken up by robotics gets replaced by the innovation and creativeness of people, because they realize that not everybody likes to do yoga in a hot environment, for example. Other people like to do a certain type of yoga that stretches their mind rather than their body. And so these are things that should be taken into account. So tip number 4 is definitely keep an eye on the future and be in a position to always upgrade yourself and update yourself. Just like we do to our computers, you should be ready to do it to yourself too. Okay, the last 2. How do you balance your workload and study? So I'm going to give you a guide here that was developed by the dean of the engineering school at the University of Kansas. And what he said was that let's assume that in a week you can work 60 hours, okay, which is quite a bit, right? But when you're young, you should be able to work 60 hours a week. And so now this work here involves your actual employment. So you may be working, let's say in a grocery store or whatever, and that time, the time to travel to there, the time to travel to college, is all the time that is involved in the 60 hours, which is your work week. So now, if you take a 1-unit class, the bottom line is, in order to do well in that 1-unit class, you need to put 2 hours of time outside of class. So every 1 unit takes up 3 hours of your time out of that 60 hours, right? So now let's say you work for 20 hours. So what I'm left with now is 60 minus 20 is 40 hours. And I divide it by the 3, which is basically 3 hours per unit of class. And that leaves me with 13 units that I can reasonably do if I'm working 20 hours a week, right? So please keep this in mind. Make sure that your workload and your study load is consistent with this guide, because there's a strong correlation between students trying to take much more than they can handle and actually leading to higher rates of dropouts from colleges. Okay, so this is something very important. Last slide, time management. By far the most difficult challenge that students face, and actually as you go in your career you will face, is how to manage your time. Because as you will see, there is, at any given moment, there's always something very important and very urgent, right? But the question is it really that? Is it really that you're always in this situation where there's always something important and something urgent? Okay? So the trick is that you want to categorize your life into these things that you think are important and you think that are urgent, right? And based on that, then you can come up with this matrix here, which consists of 4 quadrants, where in quadrant 1, you have basically you're focused on doing something that's urgent and important. Number 2, it's not urgent, but it's important. Number 4 is neither urgent, not important. Or should you put your effort into number 3, which is really urgent, but not important, okay? So here's another poll to basically find out what is it that you think you should be putting your efforts into. Which of these quadrants should you be operating in? Okay, I'm waiting for one more, then we'll be done with this code. Okay, let me wrap it up. Almost all of you have completed it. So let's have a, oh, there, okay. So here it is. Okay, so what most of you are saying is that you want to basically be spending all your time in a situation where you're always doing something that is really important and really urgent. Okay? So let me try to talk you out of that mode, because the right mode for operation is quadrant 2, where you should be doing something that's important but not urgent. And what I mean by that is this: let's say you have a final exam coming up. The question is, do you think you're going to do better if you wait till the last moment and then spend enormous number of hours on it because you know that the exam is tomorrow and it is very important? Or you basically know that the exam is very important, and then 1 week before you basically start preparing for it, and you basically have time to talk to others, you solve a lot of problems and come back. So which of these two modes will you take? You should be taking the mode where you're spending enough time. And so you should never be operating in quadrant 1. You should never be waiting to the last minute to do something that's important and urgent. You should always be in quadrant 2. Okay, so that's the last tip here. Tip number 6 is always try and operate in quadrant 2, where you're doing something that's really important, but it's not due tomorrow, and so you can do a really good job with it, and then in the end you would have done a great job, you would have learned more, and you would have been in a stress-free situation doing it. Okay. All right, that's it from my end. Thank you all for participating, and I wanted to end with saying that please contact me anytime you have questions. And I'm also going to highlight the STEM Center. As you all know, it's a fantastic resource on our campus, not only for accessing mentoring help, but also to learn about internships and scholarships. And also, I would highly recommend those of you who are interested in STEM to join our engineering club and participate in that. It doesn't have exams, it doesn't have tests, but you can certainly participate in competitions, competing against groups of your own bodies, or against engineering competitions that are running outside. For example, robotics competitions. You can propose your own ideas and pursue them. You'll get to make friends, discuss ideas. These days, there's even a way to watch movies together through the Discord server, and you can develop leadership skills. So please try and join the engineering club and participate in that. With that, thank you all for your patience sitting through this, and I'm happy to see that many of you were able to participate. And I'm going to stop now and hand it back to Rans. Thank you, Rans.
All right. Well, Ramki, thank you for being here with us this evening and sharing your experience, your journey, and helping our students with some practical tips on how to succeed in STEM. So thank you again.
Thank you, Lance. You're welcome. I enjoyed it.
All right. Well, next week, we will have our presenter who was postponed. So I encourage everyone to come back and return. She's a Kenyatta alum. She was a structural engineering major who started her own business. So I encourage everyone to please return and tune in. And thank you for viewing this week's episode. So everyone have a great evening and a great weekend.
So there was one student who asked a question in the chat that I couldn't answer. I don't know if he's still there. Jason,